Hello and welcome. In this video tutorial, we're going to take a look at the solutions to the homework for Unit 8, Lesson 1, the area of polygons. Let's begin. In question number 1, it asks us to determine the area of the following right triangle in square centimeters. Show your measurements and calculations. Now, it's meant to be a measurement and a calculation, which means it is assumed that you have a ruler handy. Well, I don't know that you all have a ruler handy, so I'm going to help you with the measurements on this one. The base of the triangle actually measures out to be exactly 8 centimeters. So go ahead and label that as 8 centimeters. The height of the triangle actually measures out to be 6 centimeters. Well, the area of a triangle, AT is what I'm going to call the area of a triangle. Is 1/2 the base of the triangle times the height. Or we could just say base times height divided by 2. It's probably easier to do it that way. Which would be 8 centimeters times 6 centimeters. Now I'm going to put the units in there this time just to kind of show you how the units play along with this. So 8 centimeters times 6 centimeters divided by 2. Well, that'd be 48 divided by 2, which is 24. Now, 24 is the answer, but you also have to go centimeters times centimeters to get the unit of area, which is square centimeters. Now, it's funny because you look at that answer and you say, well, it's written as centimeters squared. Yes, it's written as centimeters squared, but the unit is called, like the way you would say this unit is square centimeters. Number 2, a rectangle has a length that is 4 inches longer than its width. Its perimeter is 36 inches. What is its area? All right, well, here's the deal. Let's kind of go ahead and just draw this little rectangle down here to reason this out. We've got the length, we've got the width. We're going to let the width be X. Or, we could keep it as W. That's fine. No, we're going to keep it as X. We're going to make it one common unit. So we're going to let W equals X, and the length is 4 inches longer than that. So the length is going to be X plus 4. Okay, now the perimeter is length plus width plus width. Okay, or it's 2 times the length plus 2 times the width. So what we'll do is we'll go ahead and kind of use this to solve for X, and then we'll be able to then figure out what the area of this is. So we have to calculate the area. Now the area of this is pretty easy. The area of a rectangle is just base times height. So the area, okay. So for the length, we'll go ahead and put 2 times X plus 4. The length is X plus 4. And then for the width, it's just going to be 2 times X. And that's going to be equal to the perimeter we were told is 36. Go ahead and distribute the 2. And we have 2x plus 8 plus 2x equals 36. Let's go ahead and combine those like terms. And we get 4x plus the 8 equals the 36. Subtract 8. And if we rewrite this for x equals 36 minus the 8, or 28, go ahead and divide away the 4. And the width, x, which is the width, equals 7. So the width equals 7 inches. The length is 7 plus 4, 4 inches longer, which is 11 inches. So the area would be the base, or the length, that's 11 inches, times the width, which is 7 inches. And we get 77 square inches. Now in question 3, it says, which of the following expressions would correctly calculate the area of the right triangle shown below? Now, anytime we're given an angle and a side to the triangle, that should be a pretty good clue that we're going to need right triangle trigonometry. And just to kind of review that, we had our little SOHCAHTOA acronym that helped us recall the various trig ratios. So the sine of any particular angle was the relationship of the opposite side to the hypotenuse. The cosine was the relationship of the adjacent side to the hypotenuse. And the tangent of the angle was the opposite side over the adjacent side. Well, here's the angle. This is the adjacent side. And in order to calculate the area, area equals base times height over 2. Well, we've got the base. The base is 18. We need the height. The height would be the opposite side. So since we're dealing with the opposite side and an adjacent side, the only trig ratio that works with that would be the tangent. So we're going to set up that equation first. The tangent of 32 degrees is equal to the opposite side, h, over the adjacent side, 18. So we kind of start there. Let's go ahead and solve this thing for h. And the height is 18 times the tangent of 32. Now, if we throw this into, if we substitute that right there in place of h, here's what we get. We get that the area of the base is 1/2 times the base itself, which is already 18, times the height, which is 18 times the tangent of 32 degrees. And you can see we're going 18 times 18 or 18 squared. So 1/2 times 18 squared times the tangent of 32 degrees. Which looks like it's option 2. In question 4, we have a triangle plotted in the coordinate plane has vertices 2, 3, square root of 15, 3, and 4, 8. Which of the following is its closest area? I found it easiest to sort of plot this thing first before really kind of getting into it. I felt that was the easiest way to start. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Well, the first coordinate point, 2, 3, go over 2, up 3, make a point. That's one vertex of the triangle. This point over here, go over 4, up 8. That's this vertex of the triangle. Whoops. Sorry about that. Over 4, up 8. That would be this vertex of the triangle right there. And what about this one here? Well, the square root of 15, I mean, if you put that in your calculator, you know the square root of 16 is going to be 4. So the square root of 15 is about 3.8 or 3.9. It's going to be a hair under 4. So we're going to go almost to 4 and up 3. So almost to 4 and up 3 gives us a really skinny triangle like this. Our triangle would basically resemble this right here. Okay, now we need to essentially approximate its area. So the area is going to be the base times height divided by 2. Now to get the base, this coordinate right here is the square root of 15 and 3. This coordinate point here would be 2, 3. And this coordinate point here would be 4, 8. Now, the right, to figure out what the base of the triangle is going to be, the base of the triangle is essentially this point right here minus this point right here. And all we're doing is subtracting the x values. It's this value minus this value. The base is about equal to the square root of 15 minus 2. The height right here is going to be this value minus this value, 8 minus 3, which is 5. So we're using that information to sort of help figure out what the base and height are to be able to find the area. So we're going to go, the base is square root of 15 minus 2, and then the height of 5. And all of that is divided by 2. And we get an approximate area of about 4.624 square units. Question 5, parallelogram ABCD is shown with AD is 10 and AECF is a square with sides of length 8 centimeters. Okay, so we can see this square right here has 8 centimeters, that has 8 centimeters, and we know that the area in that would be, of course, 8 times 8 or 64. Well, to figure out the area of a parallelogram, think of it this way. What if you were to take this particular segment right here, and I'm going to color code it so y'all can see it. Take that segment right there, and what if you were just to kind of move it over here? Well, what would you get? You would get a rectangle that has a length or a base and a height. There you go. So in other words, the area of a parallelogram is still base times height, right? Don't overcomplicate it. The area of a parallelogram is still base times height. The base is going to be 8 right here plus the base of that triangle. So we need to find the base of that triangle. We'll do that in just a second. But it's going to be that base times that height of 8 centimeters. Okay, so let's find the base. Let's work on the base of that triangle because we need to get that base there. So we're going to have to use Pythagorean theorem to find this because you see you have a right triangle there. So this side is A, this side is B, this side would be C. You'd get A squared plus B squared equals C squared. Well, that would be A squared plus 8 squared equals 10 squared. Well, that's the same as A squared plus 64 equals 100. Now, go ahead and subtract the 64 both sides. And we can see that A squared would be 36. And when you square root both sides of that, A, this little side here, would be 6. So 6 plus 8 would be an entire base of 14. And so 14 times 8 gives you 112 square centimeters. Okay. Now, of course, there's always a longer way to do things. The longest way to do this problem, of course, would be find the area of this triangle right here. Find the area of that triangle right there. Find the area of that square right there, which you know is 64. 8 times 8 is 64. And find the area of that triangle right there. Okay, that would be the long way to do it, essentially. But all three of those areas would indeed add up to 112. The easiest way is just to take base of the entire parallelogram times height, just like you would a rectangle. And number 6, a quadrilateral has vertices at 5, -5, 2. So let's plot this. Go over -5 to the left, up 2, and we're going to label that as point A. B, we're going to go over 7 up 6. That's going to be up here. Oops. Okay, so if that's 0, 0 right there, we're going to go over 7 up 6. That would be point B right there. So the first one is negative 5, 2, 7, 6. And point C is 9, 0. So just go all the way over the x-axis and place a spot on 9, 0. That's going to be C. And D is going to be negative 3, negative 4. So go to the left, negative 3, go down, negative 4, and that is going to be D, negative 3, comma, negative 4. If we were to connect the lines of these, go ahead and connect the lines and actually make the parallelogram on this. Okay, and I kind of gave it away. It says quadrilateral, but I kind of gave it away that it's a parallelogram. Indeed, it certainly looks like a parallelogram. In fact, it looks like a rectangle. And that's what we're going to do in part A is we're going to calculate the slope of all 4 sides of ABCD and explain how the slopes prove that ABCD is a rectangle. Well, rectangles have 2 pairs of parallel slopes. Okay, what does that mean? It simply means that this side right here is going to have a slope. Now, slope means the steepness of a line. And when we first learned how to do slope, we did so in terms of what's called a ratio of rise over run. So the slope of that line should be equal to the slope of that line. And simultaneously, the slope of that side, the width of the rectangle, should be equal to the slope of the other side. So if both pairs of sides have parallel slopes, that would be defining a rectangle. And so that's what we're going to take a look at right now. Oops, kind of got rid of everything there. All right, so let's go ahead and find the slopes on each one of these. So the slope, we're going to start with AB. AB. Now there's 2 ways you can find the slope. Okay, you can find the slope using the slope equation, which is y2 minus y1 over x2 minus x1. You can do that. You can simply do it with coordinate points if you want. And so if I'm going AB, it would be 6 minus 2 over 7 minus 5, which is 4 over 12. I mean, you can do it that way. I think it's easier if each box is 1 unit in every direction, then just simply count boxes. Start at one point and go up and over to the other point. I'm going to go up 3 boxes, 1, 2, 3, and over, whoops, not 3 boxes, I'm sorry, 4 boxes, 1, 2, 3, 4, and I'm going to go over a total of 12 boxes. You'll count 12 boxes all the way over. So 4 up 4 over 12, right, would be my slope. My rise over run would be 4 over 12. Now that reduces to 1 over 3. Okay, now let's take a look at the parallel side of that, which would be CD. Well, CD, if you guys looked at CD, again, you go up 4 over 12 to get from one point to the other. So same slope. What does it mean? It means AB is parallel to, you write lines that look like the number 11. That's the symbol for parallel. AB is parallel to CD. Those are parallel. Okay, so now let's go and do the width of it. Let's do these slopes down here. Okay, now for these slopes, these are negative slopes because they go downward instead of up. So instead of going up and over, you're going to go down and over, but it's the same concept. I'm going to go down 1, 2, 3, 4, 5, 6, and over 2. Down 6 over 2. Down 6 over 2. Notice I'm doing the exact same slope both times. So for AD, which is the left side of the rectangle, I have a downward slope of 6. So I go down 6 over 2. That's the slope of -3, but I'm going to write it as a ratio still of -3 over 1. Okay, now BC is also down 6 over 2, which is a slope of -3 over 1. And again, what do we have here? We have same slope, which tells you AD is parallel to BC. Okay, so what do we know here? One, opposite sides are parallel. That's one way to tell. But also, if you look at these right here, if you looked at the adjacent segments, this one and this one, they're perpendicular to each other. Okay, and how do you know that? Because the slope here, the slope for this one is 1/3. The slope for this one is 1/3. The slope for this one is -3 over 1. They're negative reciprocals of each other. Adjacent sides are perpendicular. Slopes are 1/3 and -3 over 1. Slopes are negative reciprocals of each other. Okay, determine the length of the base and the height of this rectangle in simplest radical form. Well, basically, what we have to do, guys, we have to use a distance formula to be able to do that because one, the rectangle is crooked, and two, you're given coordinate points. So we're going to first to find the base. Let's work on the base. The base is we'll do side CD. So you could have either done AB or CD, and I'll say it doesn't matter, but I'm going to do side CD. And for that, the distance, the length of CD, we're going to use distance formula to do it. It's going to be x2 minus x1 squared plus y2 minus y, not x1, y2 minus y1 squared, right? Okay, so now we're going to go to our points here. Okay, got a lot going on in this picture. This is x1, y1. This will be x2, y2. Okay, so let's plug into that. This would be x2, x2 minus x1. So that would be 9 minus a minus 3. 9 minus a minus 3. Squared plus 0 minus a -4 squared. Well, that's the same thing as 12 squared minus 4 squared. 12 squared, not minus, plus. 12 squared plus 4 squared, which would be 144 plus 16. which would be 160. Now, 160 changes into 16 times 10, which is the same as 4 radical 10. So here's the base. And to do the height, we're doing the exact same thing. It's just the distance formula for a different segment. I'll go ahead and do BC, just because I can keep my numbers all positive. And we're using the exact same formula. This time I'm going to make this one x1, y1, and I'm going to keep C as x2, y2. Okay, so let's plug into that. So x2, y2, so we're going to go 9 minus 7 squared plus, and then 0 minus 6 squared, which would be 9 minus 7 over here would be 2 squared, and then 0 minus 6 is negative 6 squared, which would be 4. Oops, I don't want to confuse these calculations here. Write this down here. That would be 4 plus 36, which is the square root of 40. Square root of 40 breaks down into square root of 4 times 10, or 2 radical 10. Right, and that would be the height. What is the area of this rectangle? Area is base times height. So we're just going to go 4 radical 10 times 2 radical 10, which would be 4 times 2, just multiply the numbers, and then we're going to multiply radical 10 times radical 10. Just put that all together. This is the same as 4 times 2 is 8. Now radical 10 times radical 10 is the same thing as radical 10 times 10, or radical 100. Now, the square root of 100 is 10. So this is the same thing as 8 times 10, or 80.